Hi, everybody. How's it going? Good. All right, so a couple of announcements. So I have investigated as to what was happening with the TAs, and we still don't have one. So the problem is it's that many TAs are foreign students, and yeah, with COVID and stuff, it's like last semester they have issues with visas and everything. So instead of assigning TAs and not being sure whether they could actually do it or not, so they've decided to delay. And I just had a proposal earlier today, but the TA preferred to do everything online. So I said, no, please give me a TA that will be able to interact with you in person as soon as possible. So when we go back to class, we have normal, because that's, yeah. Math classes is really something where it's much easier to have a board and solve things. Actually, I like it this way, but yeah, it's having in-person interaction is good. So what's up with what's going to happen the next? So yeah, two options. Either I do it myself tomorrow, or we reschedule next week. So I think I'm just going to do it. Yeah, so I'll do online using the same link, just the TA session, which is scheduled for tomorrow at what time do I have? I don't think I have written it down. Yeah, so it's tomorrow at 11:45. All right, if I'm not mistaken. So tomorrow at 11:45, let's just reconnect and go over the exercises together. So I don't think it's all that long, but yeah, it's good if you have questions or stuff like that. But personally, I wouldn't say that TA sessions are my forte, just because teaching is one thing, and then just changing the point of view and just looking at things from a purely practical viewpoint of how do you solve them. Yeah, no, I'm not bad at it since yeah, same link. I'm not bad at it, but I think it's very good to have different people do the class and the TA sessions. So hopefully we have a TA by next week. Other announcement, I said I would be posting today the first homework assignment, so it's not finished. Maybe today, maybe at the latest tomorrow, hopefully before the TA sessions. So we'll see. Yeah, so be careful with the assignment, or it's not that easy. So you have to think a bit about it. I record the TA sessions. Yeah, why not? Yeah, I think last year they were recorded. Yeah. And actually, last year, what turned out is that the students didn't even show up for the TA sessions. So she was discouraged at some point and decided to just pre-record them herself and just post them online. So yeah, please show up. It's kind of sad to just be talking to myself. So yeah, it's useful, I think. All right, so that's about where we are at. In terms of content, you cannot. I don't think you'll be able to do all of the homework assignment after today, because yeah, it's still it's going to cover a bit more, and you'll have 2 weeks to do it. So yeah, plenty of time. Don't worry about that. Okay, questions so far? No. About so yeah, today's chapter 3. In my opinion, actually today's lecture is very easy. So if you, but please don't judge the whole class based on what you're going to see today, because it should be something that's just something that you're quite familiar with. It's going to get ever more involved as the weeks go by. Okay, so let us start away. All right, so today's equilibrium. So what's an equilibrium in economics or in science in general? So here's my 2 cents on it, and it's quite close to what the book says. So it's a situation of an economic model. I'm going to see an economic model in because obviously that's a notion that's in quite a lot of domains other than economics, where all variables of interest do not tend to change on their own. And where the parameters remain fixed. Actually, maybe let me invert that. Where, and so that seems more logical to put it this way. So because why would so it's, you can think of anything like for instance supply and demand, and so why would supply or demand change? Well, imagine that we are at equilibrium right now, and then something changes that's not inside the model. So for instance, taste change, or yeah, so production costs change. And then so if we stay at the same point, then of course, if for instance production costs increase, then firms cannot make a profit and they go out of business. So there's no way that the same quantity and price would be an equilibrium in that case. So it is because, so how do you get a situation where you're at equilibrium? It's when the parameters stop changing, so they are fixed, and you wait for a while. Or if it's an instantaneous model, then you just solve for equilibrium. But if it's a dynamic model where you allow for the equilibrium to take some time to settle, and you need some, I don't know, differential equation to know how fast it's going to take to reach the other equilibrium, then what you have to do basically is wait. And for a quite a long time, maybe at the end of time, then everything would be at equilibrium. All right. So something to ask, so why do I say variables of interest? Well, sorry. So because in a static model, like partial equilibrium, for instance, then everything is at rest. So all variables are at rest. But in a dynamic model, for instance, something that you will eventually see I think, in macroeconomics, maybe not in undergrad, certainly in a graduate study in macroeconomics. So a solo growth model. So some variables may be changing, yet the would be in you'd say dynamic equilibrium, or the technical word would be on a balanced growth path. So, but that's more advanced, but it's just words I'm seeding in your mind. So what does that mean? It means that, for instance, if you're looking at a country that has a population growth, then when is the country at equilibrium? Well, you could say it's never at equilibrium, because you add more people all the time. So the GDP grows all the time, investment grows all the time. So you don't have a notion of equilibrium where not everything is static. Yet you would say that if the population grows at a steady pace, always the same growth rate, then it would settle on what you call a balanced growth path, where all the variables grow at the same speed, essentially, at the same rate. But yeah, in the sort of equilibrium that interests us, like partial equilibrium, then everything is stable. Another note. All interdependent variables, but must be simultaneously at rest. Somebody can have an intuition for why this is the case. No, is everybody as sleepy as I am? Let's just go and take a 10-minute nap, then we can come back. Okay, I'll just ask randomly some people. Let me just look at who's online. All right. Mr. Steve's son, or I don't know if I'm pronouncing this correctly. So do you have an opinion on this?
I think they need to be addressed to maintain the validity of the study, I guess.
The validity of the study.
Yeah.
Yeah, I'm not really talking about the study itself, but what I'm saying is, why would an equilibrium require that all interdependent variables be simultaneously at rest?
Well, if they're interdependent, that means a change in one of them will affect a change in another, right?
Yes, that's a good answer. Because if one variable, so if they are all at rest, then one changes, it puts all all the other dependent or inter variables out of equilibrium. It's yeah, simple as that. All right, so let's look at static models. I don't think I'm ever going to look at dynamic models, so don't worry about this. And especially partial equilibrium. So yeah, now we're digging back into economics. So we've done some very high level math with sets and ordered pairs or tuples and all that jazz. And now we're back to some economics. So if somebody thought, oh, I'm lost, is that an economics class? Yeah, it's an economics class. So example, supply and demand. So the question is how the market price and quantity determine. So if I want to be formal, I'm going to say something. So I have two behavior equation. Which will be the demand equation. So I'm going to write it this way, QD. So for quantity demanded equal to, and then I can write f of p, for instance, but I'm just going to write equals QD of p. So QD here is a value, and this QD of p is a function, right? So, but it's the name I gave it to it. So it's just a neat way because to sort of overload this QD variable. So can we say something about this QD function right now? Is there something you would know about its shape? So it's something we would have seen not maybe last class or the class before, or something you should know as economists. It's neither. It could, but it doesn't have to. Yeah, so if I write it, so it's a good guess to imagine that I'm going to give you a nice linear function. Yeah, but something a bit more fundamental than that. Yeah, function is a function. So yeah, in a sense, what we're saying is for every value of p, there is only going to be one value of q. So that's true. Quadratic. Yeah, if I'm less nice with you, I can give you a quadratic. Actually, that might be a good idea for the exam. Yeah, I hadn't thought of that. Thank you. Would you like a quadratic demand equation at the exam? Could give one. So no, nobody has come up with what I was expecting. No, thanks. Okay, I'll take that into account. So, well, we know it's, so we know one thing, what happens when the price goes up? Yes, demand goes down. So it's probably a negative function. Yeah. Yeah, and then two, I would have the supply equation. Yeah, so it doesn't have to be in all cases because given goods can exist, but they are very, very rare. So what can we say about that one? Yes, thank you. So, but it's a positive function. All right, and so these are my two behavior equations. They describe how consumers react to a change in price, how firms or suppliers or producers react to a change in price. And now I need one other equation to set the equilibrium, to discover what the equilibrium is and what is it. Yes, good. So one equilibrium condition. So supply equals demand. So that means Q equals QS. So when you're asked, please define an equilibrium. So this is the kind of thing that they ask. So they say, what equilibrium, what equations do I need to find a unique solution to my model? So here, how many variables do we have? So we have number of variables. Three. We have QD, QS, and P, and number of equations. Three.
Batterie 40%. Connecté à MICOLS HP.
Yeah, for some reason my microphone stopped working, but now it's working again. Okay. All right. So here, usually, if we have these three, the same number of variables and the same number of equation, we are. It looks like we might be in good shape. So it's not enough to be sure, because you have to have the good shape for the main equation and supply equation, but since they are a negative function and a positive function, especially if I'm going to add if they are linear, then yeah, we should be able to find an equilibrium there. So let's go with, yeah. Oh yeah, and so two things that I may add here. Implicit assumptions that I'm not going to say, but that do exist. So QD and QS are greater or equal than 0. This, since we're doing economics, we can assume that this is the case. All right. So linear example. Let's say I have QD of P equals 9 minus P. And I have QS is 2P. And so here I don't have an extra tax paid by anybody, so it's just there's just price everywhere. Okay. What can I do? I can solve it right away. So all right, let's do that. So please solve this for me. Oh, and yeah. So third, yeah. So that would mean that I have QD equals 9 minus P. QS equals to P. Yeah, and QD equals to QS. So what we can do is, right, one way to do it. So this is why I'm saying it should be easy for you, because if you've been doing economic for a while, then you might have encountered this sort of systems. So solving. So what I can do is using the third equation to substitute the first and second. So there's many different ways to do it. So I get that 3P, 9 equals 3P. So P equals 9 divided by 3 equals 2, 3. And then if I want to find the finding the equilibrium quantity, what I can do is simply substitute 3 here. So using, so what I can do is, yeah, QS of P of 3 equals 2 times 3 equals 6. All right. So the equilibrium is, so I can label them by, I like to use asterisks to label them. So I'm going to say it's QD star, QS star, and P star. So it's ordered, not an ordered pair, but a tuple of 3 values, which represent the equilibrium, and is, of course, this is 6, 6, and 3. So this is how you would do it. All right, questions about this? It's all right to have any inquiry. If you have an inquiry, then you're not alone. I always wonder, is it too easy, or yeah, maybe, or too difficult, or I think it's all right, but just in case. Okay, now representing this. So now this is something that we may want to do, but we oftentimes in economics, for that we put prices on the vertical axis and the quantities on the horizontal axis. So then to do this, what we can do is simply invert the function. So inverting the functions. So what we have is QD equals 9 minus P. And what this can do to us is we can just set price on the left-hand side, quantity on the right-hand side, and just express this as this way. PD of Q equals 9 minus Q. All right. Same thing with the other one. QS equals to P. So I'm going to write as just 2P equals QS. So I can divide this by 2. And then this is rather my function. So it's PS of Q. So 3 to express the fact that it's now this is the function of Q. And I could, of course, solve it this way too. I could start by inverting them and solve them this way. And now my equilibrium condition would be that PD equals PS, right? So note, invert functions and add as equilibrium condition PD equals PS. So here what you would say is, of course, you would already be implying that the quantity has to be the same. So you're by assumption, you assume that the market is there's no excess production or excess demand, but you have to make sure that the price that the consumers are willing to pay is exactly the same price as the price that producers are willing to accept. All right. So this is another way of expressing it. And all right, so now we could go ahead and draw that. So to draw it, we can compute different points. So for demand and supply. Somebody have suggestions for this? Ah, thank you. So here I had so just remove this. I have QS equals 2P. So I divide by 2 or on each side. P equals Q over 2. Right? And now I just said, now this is going to be the price by the suppliers, and it's going to be a function of Q. So this is just, I just divided by 2, basically. All right, so I suggest, well, we already have one, so use the equilibrium that's already been computed. That's quite easy. So I have Q and P. So, okay, yeah, use the equilibrium. So for demand, so I can have something like, so what I have to plot is this. So I know that one point is going to be QP equals to 6.3. And I can have another one. So let's have Q equals 0. So if Q equals 0, then I get P equal 9. So, or um, 0, 9. That's an easy one. And supply. Yeah, rather, I think I'm going to write it this way. So 6.3 is already something I've computed before. And now I can use my supply is this. So what I can do is, yeah, so if I have 0 here, I have 0 there, right? So 0, 0 is a good point. So that's an easy way of finding the points. So pay attention. This is something that you are likely going to have to do in the homeworks or in the exam. All right, so let's go ahead and draw this. Okay, so what points do I want? I want 6, 3, 9. Yeah, so let's just say, yeah, let's just try something, see if it works. Yeah, let's have a nice small one. That's quite good. So 9 is going to be there. Just going to use the ticks there. And 1, 2, 3. So the man is 9, 0 and 6, 3. Oh yes, so that's not 3 here, that's 6. 1, 2, 3, 4, 5, 6 there. And 1, 2, 3. So that's 1 point. One was 9, 0. And one was 0, 9, I mean, and 0, 0. And here we go. Can draw this. So that's the supply and demand. And yeah, if I want to be exactly precise, then I should show this, maybe just to show that, yes, the demand is not going to be negative, because I said so in the assumptions of the model. But yeah, this is nitpicking. I'm not going to make you lose points if you don't do that. Okay, so one thing you may, so anytime you do this, then please indicate what curves they are. And if it's not here, it looks obvious. So yeah, but just to make it even more obvious, what you can do is have some points like this, just to show that here we are this. And yeah. Or you could just show, say, 6, 3 there. But yeah, this is pretty good. I would be happy with that. And then you show that this is P. Here, I think I don't have a small d, right? Yeah, PDF Q. And this would be P S. Oh yeah, I have one. That's nice. And this would be Q. This would be P. All right. So I'm guessing it's not. It won't be the first time that you draw this sort of graph, or it might be. I don't know. So this is the sort of thing that will make me happy. All right. So if you show what's on the axes, if you show where the points are, or if you don't want to indicate them here, just say something like this is 6, 3, for instance, just to tell me what to indicate what they are. No, you don't have to. Well, if it's if since the exam is probably going to be in person, then I won't judge if you don't bring color or pencils. I tend to use always blue for demand and red for supply. It's just a convention I use. So yeah. And yeah, am I missing something there? No, I think not. So I'm happy with this. All right, so let's save this for later. Okay. So do I have other stuff to say about this? Yeah, so for fun, on your own, practice solving it from the inverse demand supply. Oh, by the way, these are called the inverse demand and supply. So this is the inverse the inverse, and this is the inverse supply. So these are really the name that you will encounter in the wild. So you can, yeah, so solving it using the inverse demand and supply. Yeah, so this, you're obviously going to have to do this kind of thing at some point. Yeah, so I think I'm going to always represent this with price on the vertical axis and quantity on the horizontal axis. All right. Okay, so questions about this? Comments? No? So one comment I have is, so back to set theory, just to close the loop with what we have learned so far. So using set notations, what you could say is the demand is a set of points or a set of ordered pairs, Q and P, such that Q equals 9 minus P. Oops. 9 minus P. And obviously the supply is a set of ordered pairs as well, or a set of tuples, such that Q equals 2P. So this is an infinite number of points. This is an infinite number of points that represent a line. And then the equilibrium is Q star and P star, such that so it's simply the intersection and of DNS, right? And it's so the intersection is, as we have said, 6 and 3. So this point there, the equilibrium, is the intersection of the whole set of points that are representing the supply curve and the whole set of points that are representing the demand curve, right? So this is a neat way of representing it. Okay, very important note for exams. So when I say solve something, I want you to solve it. So anytime. But I don't think it's when students don't do it properly, I don't think it's because they don't understand what's being asked. I think it's mostly because they just don't know how to do it. So rather than writing nothing, they do their best, but it's not enough. So in exam, when you are asked, to find a solution, you always assume that it is an explicit solution in terms of the parameters of the model. An explicit solution in terms of the parameters. Because you could perfectly say the solution is D intersection S, right? It's like saying, oh, the solution is what is asked in the question. It's true. If I'm saying, please find the equilibrium, meaning the only set of quantity and price such that that are compatible with the demand and the supply. So you can say, well, your solution is the point that is contained in the set of points in the demand and in the supply. Will that fly? No, because so for instance, a good solution is P star equals 3, and then Q star equals 6. So that is a good solution, right? Because you don't have any variables here. You just have numbers. The numbers come from the parameter of the problem. And if you say, so this is good. And if you say P star equals 8 minus Q star, for instance. So this is not a good solution. So you're saying, yeah, imagine a world in which I have given you Q star, then it would also give you P star. I don't want to imagine stuff, okay? I want to be sure. I know you're smart, but just help me there, give you points, right? So convince me that you understand, you know how to solve a system of equations. So I see this many times. Students, they don't really know, so they say, all right, sorry, this would be demand is 9. Okay, so 9 here. So this is not a good solution. Why? Because Q star is not a parameter. All right. So yeah, I wouldn't be too thrilled if you said that, because I know what you mean, but it's I'm not sure that you know how to solve it. If I ask you solve it, this is what I'm asking. Okay. All right. So some other question? No. So application to the atom. We're going to see it again. So that's another very nice feature of the book, is they always have a micro model, which is solving a system of linear equation like a partial equilibrium model, so supply and demand. Yeah, for some reason, my microphone, always cuts. Okay. So I don't know what's wrong with it, but it always cuts. Okay, so no. Yeah. So as I was saying, Yeah, the nice thing about the book is they always have a small macro model and a small micro model. So I've solved it for the micro model, so you could do the same thing for at home. So simplest Keynesian model. So we have y equals c plus I0 plus G0. And you could have c equals a plus b. So let me explain to you. So y is output, GDP. C is consumption. I0 is investment that here we assume is some set value that's a parameter of the model, and G0, which is the government expenditure, which is also given. So there's really, yeah, or I could just ask you a bunch of questions about them. So where, why is national income? C is consumption. I0 is investment. Constant. And G0 is government spending. And it's also constant. So that's why there's a subset 0 there. That's just to say it's the base level. It's something that's always there. And we have A is greater than 0. And B is between 0 and 1. So a bunch of questions that you can ask for yourselves. So questions. Which are the variables? Which are the parameters? I could just ask them to you right now, but I want everybody to just ponder a bit about it, just to practice. If you have questions, if you're unsure, then just email me and I'll help you. And then find the equilibrium values in terms of the parameters. Yeah, no, all caps seems too extreme, but that you understand what I mean. Yeah, so all cap writing is not very nice. All right. And I also have a small quiz for you. On this stuff. So it's a bunch of things on finding equilibrium. So when did we start? We started at 15. So we have until, I always forget. $2:30, right. Okay, so we have 15 minutes left. Yeah, so yeah, we're doing good. So this do on your own too. Oh yeah, by the way, I think I haven't corrected the last quiz I gave, right? Oh, I could just do that right now. So that would be it for this section. Next time is, we're going to solving quadratic equation. But for now, we're done with this. And let's just have a look at the quiz briefly. Should have said something. Sir, we spend a lot of effort finding the solutions for the quiz. Okay, so thinking about the shapes of letters and the definition of a function, two of the following letters are function. Which ones? W, P, V, and F. So this is sort of a cheeky question. So I'm not going to ask weird questions like this in the exam, don't worry, but it's just for fun. So what you have to look is what's important. Oh, and by the way, it's not very well done. So a lot of people thought F was a function. Is it because F is the first letter of function? Yeah, so the important thing was shapes here. So if you imagine that you have the vertical axis here and the horizontal axis, then what's a function? A function is a function if for every value of x, there is a unique y value associated with it. So W, is that a function? Well, yes. Why? Because you see that it's so you give something like this, and there's a single value of x associated with each height of the letter W, right? So that was the tricky part of it. V was a function too. Yeah, so this that was a popular answer. Why? Because again, you have for every x, you have a single value of y. P is not a function because you have the this double bar there that gives you two values of x for one value of y. And F is not a function because you have these two values of F that for here, it's a bit like the same problem as P. Plus, all this bar is nonsense too, because here you have a very, very large number of. So I'm curious, maybe I can change it for next year if it's too weird. So did somebody did not get any of it? If it's too confusing, I'm going to remove it. Oh, you could only choose one. Oh, geez, so that means, oh, I have to fix that, sorry. Yeah, that's how Google quiz are done. I can make it such that you can select many of them. It's just, yeah, that's something okay. Change option sets. What? That's why there was only two W. Yeah, okay. So sorry about that. So it was, I hadn't realized that that was the case. Okay. What are the maximum domains of the following functions? Okay. Well, I hadn't realized that was done like that. Yeah, so R is the right answer. Why? Because X can take any value. So you could have minus 100, plus 100, or plus 1000, doesn't matter. Y, though, is limited to the positives. So the range is only the positive reals, but the domain is all of the reals. So here the trick is to just remember the definition of what the domain is. And that should be good. Y equals log of 10 of X. Yes, R positive is the right answer. For this, you have to remember what log is. Yes, so I last class I talked about the domain and range. So domain is all the possible values that X can take, and range is all the possible values that Y can take. Right. So yeah, it's just this. I wouldn't write this in the exam because this is it's an important concept. So I could ask you this sort of question: what are the maximum domains of the following functions, or what are the maximum range of the following function? Yeah, codomain I'm not going to ask you. Square root of X, so R plus, it's the right one too, because you cannot have X taking -1, for instance, in R, because I said in R. No, usually for the reals, you assume that 0 is included in them. Yeah, that's a it looks like a minor point, but it's like it's however I choose to define the reals. But so I'm telling you, yes, 0 is included in the reals, in positive reals. Otherwise, that would be strange. No, you would have like 0.00000001 would be included, but not 0, for instance. So it's or arbitrarily close to 0 without 0. That would seem strange. So it's just the integers include 0 as well. So it's just the natural numbers actually that that do not include the 0. Yeah. All right. Yeah. So here it's for all the reals. Yeah. So maybe I could. By the way, I could show you what I mean by. I don't know if you've been on Google, but let's just try and y equals log of X. Yeah, so this is the sort of thing you get if you write them in Google, and you see that X is limited to the positive reals. Second one was square root, so you would write X 0.5. And you see, it's limited to the positive values. And then the third one was to the X. I don't know if that's going to work. Oh yeah, it is. So you see that you could have as small values as you want, and even though it looks like it's exploding, it's going to infinity. And then the last, yeah, that was the last one. All right. Yeah, so the range is so that's the same question for the range. So here, this is positive values because it's an absolute value. So we just get rid of the minus sign. The all reals because it goes from minus infinity to plus infinity. Just the positive values because since X cannot be so I would have to write plus or minus here. if I wanted the plus and the positive and the negative values. And yeah, here, this is obviously just the positive values, as you can see here. Associate the graphs with their equations. So that may have been a bit, oh, we don't have the drawings there, don't we? Oh, Tyler, so was it a question about one of these? So about square root, for instance? Yeah, so if you want to solve x equals y squared, then you would have two solutions. You would have, and you want to find y, so you would have y equals plus or minus x. But if I'm giving you y equals square root of x, yeah, so the square root is defined as positive values. Yeah. And you have to add the plus or minus in front of it if you want a negative value. Yeah, so I don't think there is much more I can say about it. I would like to elaborate, but yeah. Oh, so that's sad that I cannot show you the equation. So let me try and see if I can open this in another window. Yeah, all right. Questions. And I'm going to change my sharing. Okay, so okay, so what is A? This is a linear function, so it's quite easy. I should have a linear function. So A is, yeah, that one is a linear function. That one, y equals x squared. This is a quadratic. So, well, actually, it's quite easy. You can just use Google and do it. So, but still, it's good to have that in mind. That was not too difficult. Y equals x squared, x cubed minus 10x squared plus 4x plus 10. So the way to look at it is you look at the first, the biggest exponent. So that's 3. So you should have something like potentially 3 zeros, as many zeros as the largest exponent. And yeah, and yeah, it should be curvy. So that's this one, obviously. Log of x, so that's this one. So yeah, that was quite well done. E to the x, that one. And yeah, sin x times x. So by elimination, you get that weird squiggly line. So yeah, that was it. So yeah, good job. I think most of you got it quite well. All right. No, you're not going to have to draw, especially not that one. No, I don't want to say that. So you might have to draw polynomials like this one, for instance, or that one. Exponential, I wouldn't think so, but yeah, polynomials are quite neat, quite useful. So yeah, you might have to draw 1 or 2. The thing is, I might ask you to do, but it's quite close to the end, is something like find all the maximum. So here you have a maximum, minimum, and inflection points. So an inflection point is where the derivative start changing changing size. So here it's all the derivative is decreasing, 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 and then here it starts increasing again. So here would be an inflection point. So you would have to find this inflection point. And if you have all of these things, then you can draw more or less the drawing. All right, so very quickly, since we're over time. So that one, so that's just a small joke with, I really like emojis. So log of, what is the log of happy face with an exponent that's water droplet? Well, the water droplet goes in front of it times the log of the happy face. So most of you got it right. Yeah. All right. So this is just to refresh your memories about the laws of exponents. All right. So that's it for now. I'm going to, and I see you tomorrow for the tea session. And I'm going to post as soon as possible your first homework assignment. Okay, so have a nice afternoon and I see you soon.